If I want to actually do mathematics on it, I'm going to have to call it 0.48.
Okay.
Hey, Sean.
Yeah.
We're kind of confused here.
How did you get that point?
103 divided by 214. So 48% of the time, it took us one flip to be done. Is that fair?
Exactly what I'm saying.
I was trying to tell. I was
Oh, I
trying
see.
to
You would have to divide.
We're all friends here. They're not at each other because of mathematics. That should be a peaceful endeavor. 23%, 13%. Let's make sure I'm getting this correct. 9%-ish. 2-ish. 4. That was a hiccup. And then about 1. Add to 100. That might not add. This might be one of those cases, Pat, where it doesn't quite add up because of rounding. Oh, it does. The Veronica's already checked it for us. So this does add to 100%.
That's crazy.
Or 1, I guess. 100% 1, whatever you want to call it. And again, Alan brought up a very, very good point before I turn the camera back on. I originally had a percentage symbol up here, and then I put 0.48, which can be confusing, because then it looks like 0.48%, which is definitely not what it is. It's 48%. But because I'm me, I like to use the decimal versions versus the percentage versions, because if I actually want to do something with that, you have to change it to a decimal first. Is that fair? You guys buy that logic?
Yeah.
Okay, now once you have that, would you please average? Because technically speaking, you now have an experimental probability distribution. This is an experimental probability distribution, right? It's experimental. P of X. It's not theoretical because we didn't like turn the dice on our hands to figure it out. But we did experiment and figure this out. So we can treat it as if it were a probability distribution. This is going to link us very nicely into Thursday. Thank you. Monica, go.
So we're not putting the frequency, we're putting the percentage.
You can put the frequency in and then do the division. But yeah, I want you to average these two right here. I want you to average this guy with that guy. For sure. For sure. And I'll draw some boxes around that so you know what to average. So average this. That's your data. That's your data. Here's your relative frequencies that you want to average them against. Everybody buying that? So it's the same thing as the dice, except the dice are no longer behaving like they usually do. Now you've got this goofy distribution where 1 is the most common roll, 2 is less common, 3 is less common, 4 is less common, 5 is, and so forth and so on. See what you're going with. You can graph it too. Graph would be kind of fun to look at.
What would you say? Actually.